Now, in relation to energy, because as the ball rolls down the incline, it loses a certain amount of potential energy, which is then converted to kinetic energy. In any case, then, if you have twice the slope on a ramp of the same length, you have very nearly double the kinetic energy, or the potential energy change, so you ought to have pretty much double the kinetic energy. So my question was, if you have double the kinetic energy, well, what's the ratio of your two velocities? Okay, if you double the kinetic energy by making the ramp twice as steep, what happens to the ratio of your kinetic energies? And I should probably write that down, okay? Doubling the slope pretty much doubles change in potential energy. So KE pretty much doubles, leading us to this question. Because after the ball gets to the end of the ramp, it becomes very much an ideal projectile and follows a parabolic arc to the floor. You can measure how long it took, how far it dropped. You can easily measure the slope of the ramp. And there are all kinds of questions that you can answer and that you're going to be asked to answer. Okay, so the first question is, relevant to that, if the ball comes off horizontally, which it doesn't because the ramp is sloped, but if it did come off horizontally, what would we expect the ratio of the horizontal ranges to be? Well, if the ball comes off horizontally, it's got zero vertical velocity, so the time of fall is always going to be the same. So if it had twice the velocity coming off, it would travel twice as far before it hit the floor in the horizontal direction. Vertical displacement is going to be the same in each case. As a first approximation, we're going to assume that the ball does, we're going to ignore the fact that there's an angle and just approximate what the velocity of the ball would be. And I even gave the approximation, because it's not going to do you any good when I ask you to do the real stuff. I gave you the approximation. It takes roughly 4/10 of a second. I actually think it's somewhere between 43 and 44 hundredths of a second to fall the approximately 95 centimeters from the table to the floor. And you're welcome to use that in doing approximations, but of course, when you solve problems, we're going to want to do it from basic principles. Okay, well, that's saying a lot around the question of, if you have a 2-to-1 ratio of kinetic energies, what's your ratio of velocities? Well, the first answer I got was 4. Well, that's not right, but I believe that the thinking was along the right lines. I believe the thinking was, well, kinetic energy has V squared, so if you square 2, you get 4. Yeah, that's pretty good thinking, you know, for somebody at the first part of a physics course. It's wrong because you went the wrong way with the power, but I believe that's what was being used. Well, it's fairly easy if you write this out carefully to get it right, but that was a good intuitive answer. Totally misleading, but still was a pretty decent response. Okay, so let's see. What is V2 over V1? Well, kinetic energy 2 over kinetic energy 1 says you divide this kinetic energy by this kinetic energy. Well, what kinetic energy? The kinetic energy you have for the second velocity divided by the kinetic energy you have for the first velocity. And what is that? Well, I'm going to just say kinetic energy 2, we're going to call it 1/2 m V2 squared, so that implicitly in calling it this, V2 is the velocity you get on the second ramp. And kinetic energy 1 is 1/2 m V1 squared. And you simplify that, you just divide the 1/2 m's, and you get V2 squared over V1 squared. And that's equal to the ratio of kinetic energies, and that's got to be 2. It follows then that V2 over V1 is the square root of 2. And some people got that after I made some comments here, so that was very good. Okay? And that means that when you do the experiment, you kind of expect the ball on the ramp that's twice as steep to go something like about 40% further before it hits the floor than the one on the less steep ramp. Now, there's another factor involved, and that's that on either ramp, you got a vertical component of that initial velocity, so the ball doesn't take quite as long to fall. And that's going to mess with this square root of 2 ratio, which is why you aren't really going to get a square root of 2 ratio. Okay, well, we're going to talk about some other data that needs to be collected and how I'm likely to ask you to analyze it.